Hello, this is Mr. Bainey, and this lesson is 5.2 using intercepts. The essential question is how can you identify and use intercepts in linear relationships? In this explore activity, miners are exploring 90 feet underground. The miners ascend in an elevator at a constant rate over a period of 3 minutes until they reach the surface. In the coordinate grid, the horizontal axis represents the time in minutes from when the miners start ascending, and the vertical axis represents the miner's elevation relative to the surface in feet. So 90 feet underground is where they start. So 90 feet underground, we can think of that as a negative 90. Since they start there, that's when the time is 0 minutes. So that's going to represent the point. So this is part A, what point represents the miner's elevation at the beginning, and that is the point 0, comma, negative 90. Okay, and so we start with the description of what this point means, where we begin, and then we put that onto the graph. Part B, what point represents the miner's elevation at the end of the ascent, and that is the over a period of 3 minutes until they reach the surface. So we can think of surface as like when the elevation is exactly 0. So they're not underground or above ground. And so when 3 minutes is up, the miners will be at 0 feet elevation. So that's going to be the point 3, comma 0. Part C, we're going to connect these points with a line segment. So I'll try my best to draw a straight line here. And then what's the point where the graph crosses the y-axis? So we're going to pretend here, and you don't necessarily have to do this, but imagine this line is going on forever. Then that means that it's crossing the y-axis at 0, comma, negative 90, the very first point that I put down. And then it crosses the x-axis at the point 3, comma, 0. Okay. So these 2 points are going to be very crucial points when we're dealing more with linear equations, linear functions. That's what we started with in the previous lesson. And y-intercept is, the y-intercept of the graph is where the graph crosses the y-axis. So the way we think of it here is y-intercept is where it crosses the y-axis. And when any point that's on the y-axis has an x value of 0. Okay, so when the input is 0, we want to think about what is our output? What's that y value? And on the other hand, x-intercept is where the graph crosses the x-axis, and every point on the x-axis is going to have a y value or a y coordinate of 0. So this is telling us that the output is 0. Now we got to find out what that input is. So again, two of the most, I think the most important points on a linear function are going to be the x and y intercept. It's going to be useful for us when we're dealing with word problems. Okay, so let's try this out. On the your turn, number 3, we're going to find the x and the y intercept. So we have 8x plus 7y equals 28. To find let's do the y-intercept. Means that x is going to equal 0. If x is 0, we have 8 times 0 plus 7y equals 28. And if you look back at the original problem, when we plug in y for 0, you can almost like cover the 8x, and you can look at what we have left over. We have a positive 7y equals 28. And 7y equals 28 is a much easier equation to solve. It gives us y equals 4. So this means we input 0 for x, and we got an output of 4. And that leaves us with the point 0, comma 4. So here's our y-intercept, and the x-intercept let me do it off to the left side here, is when y is 0. So we got x-intercept is when y equals 0. So we have 8x plus 7 times 0 equals 28. Well, 7 times 0 is 0. That goes away. 8x equals 28. And divide by 8 on both sides to get 3.5. And that means the x-intercept is 3.5 comma 0. Okay. If you have not tried the number 4 yet, your turn. Give that a try before you see the solution. Okay. Y-intercept means that x is 0. Whoops. So negative 6 times 0 minus 8y equals 24. So the negative 6 times 0 goes away. Negative 8y equals 24. And y is going to equal negative 3. Probably the biggest mistake here is going to be dealing with that negative. Make sure that you are not leaving that out. So that's our y-intercept. Our x-intercept is negative 6x minus 8 times 0 equals 24. And negative 6x equals 24. And therefore, x equals negative 4. Our point for the x-intercept is negative 4, comma 0. Okay, now we're going to apply this to a real-life situation and see how we interpret it once we find both the x and the y-intercept. So let's go to the your turn. If you want to practice before you see me do it, finding the x and y-intercept, go ahead and give that a try. So we have the temperature in an experiment that increases at a constant rate over a period of time until the temperature reaches 0 degrees Celsius. They give us the equation right here. This equation gives the temperature y in degrees Celsius and the x in hours after the experiment begins. And we're going to find and interpret the x and y-intercept. So the y-intercept is going to equal 5/2 times 0 minus 70. So this one is actually really easy, and we get negative 70. So the y-intercept of 0 comma negative 70, think about what this means. This means that the 0 is our hours. The negative 70 is our degrees Celsius. Okay? So one way that we can interpret this is at 0 hours, the temperature is negative 70 degrees Celsius. Another way to interpret is you could say at the beginning of the experiment, the temperature is negative 70 degrees Celsius. That's probably a little bit more accurate because when we say at 0 hours, we normally don't say that. We would say before the experiment or at the beginning of the experiment, this is the temperature. Okay, it sounds a lot more, makes a lot more sense, sounds a lot more natural. And let's find our x-intercept. That means that y is 0. So the equation y equals 5/2 x minus 70 becomes 0 equals 5/2 x minus 70. And this is going to be a little more challenging. I'm going to add 70 to both sides, and I get 70 equals 5/2 x. And there's a few ways you can deal with this 5/2 because we need to get rid of that. You can divide both sides by 5/2, or you can change that to a decimal, right? That's a 2.5. You can divide both sides by 2.5. You can also multiply by the reciprocal of 5/2 because that'll help get rid of it. Or it's the same as dividing by 5/2. So when I do that, let's see, divide by 5 or so what I'm multiplying by the reciprocal, so 2/5. So if I divide by 5, that is 14 times 2, 28. So I'm going to end up getting x equals 28, and therefore the x-intercept 28 comma 0 is what I end up with. Remember that 28 means hours, and the 0 is the degrees Celsius. And if you read the first sentence again, it says at the end, until the temperature reaches 0 degrees Celsius. So this experiment continues until it reaches 0 degrees Celsius for the output. So you can say something like, after or at 28 hours, the temperature is 0 degrees Celsius. Another way you can interpret this point is you can say the experiment ends after 28 hours or at 28 hours. Okay, and the last thing that you should be able to do, pretty similar to our first example that we looked at, our first couple examples, and that is to take an equation, find the x and y intercept, and be able to graph it. And I'm going to show finding the x and y intercept here, except in your textbook, there's a typo because they shouldn't have graphed it for you on this your turn. That you see they have the graph on the right side. They shouldn't have had you do it, but we'll just verify that this graph is in fact correct. So let's find the x and y intercept. If you think you can do this, go ahead and give it a try. The y-intercept will become 3y equals 5 times 0 minus 30. I'm sorry, it should have been negative 5 times 0. Not that that matters in here, but it's going to be important when we do the other one. So 3y equals negative 30, and that means that y equals negative 10. So we have the point 0 comma negative 10. And that is down here at the bottom on the graph. The x-intercept is 3 times 0 equals negative 5x minus 30. So I get 0 equals negative 5x minus 30. Let's add 30 to both sides. And I get this equation. Divide by negative 5, and that'll give us x equals negative 6. So the x-intercept is the point negative 6 comma 0, which is right here. And you'll see both points are on the line, and what you would do is you would draw a line through those 2 points to graph it. And this is different than our previous process of graphing lines, which is to possibly solve for y, just to make it a little bit easier, pick some inputs, and then figure out the outputs, and then graphing those points. So this is a slightly different method. We're still finding some values of x and y when one of them is 0. Okay, that is it for this lesson. Thank you so much for watching. I hope this was helpful. Have a great day.